I am Dr. Praveen Chaurasia, working in the Department of Electronics and Communication Engineering at IMS Engineering College, Ghaziabad, which is affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. In this fifth lecture, I will talk about the introductory portion of digital image processing, which has the code that is KEC 071. And in this introductory part, I am talking about one of the important technique that is called sampling and quantization technique. And after that, we will talk about the halftoning process, which is actually useful in digital image processing. So, before that, we will also identify the sampling technique, how we can identify, how we can extract the digital image from the simple image, and how we can quantize each and every pixel to get the complete information of each and every pixel, which is the smallest quantity present in digital image. So, that thing we are covering in this lecture. So, let us have a look. So, if we talk about the digital image, then you can observe this diagram more number of times. So, see, if some illumination source, which is actually the power of energy, which is actually the giving the energy towards any object. So, see, if we have this scene element or object, then that source is actually providing the energy, or you can say light on this particular object, then that light or that power is actually reflected back, and using the imaging system, or you can say human eye, if it is observe this reflected light, then that object is actually able to see for this system or your brain. So, that is actually the process by which you can identify a single image. After, if we talk about this imaging system, then that imaging system is actually draw this object in this manner, this pictorial manner. So, see, in a grid form it will look like in this manner. So, that is the portion which is having a complete look of this object in grid form, and after the some process by we can say sampling process or quantization process, it will generate this image, and that image is actually is calling a digital image. Why it is so? Why it is digital? If we talk about this image, then see some of the portion, these are the grid. Okay. So, it has the so many rectangle portion. So, some of the rectangle is not filled completely here, and in this diagram you can say that portion is completely filled, that complete rectangle is totally filled, but that rectangle is not that completely filled. So, it is still a unfilled portion. So, in digital image, whether it has to be there, otherwise it has not to be there. Okay. So, whether it has the 0 value, if we see, if we are taking the gray level for white color, that is 0 level, and for the black color, if we are observing highest level, that is 255 gray level. If we talk about 8 gray level, then you may observe for white portion each and every rectangle has 0 value, and for the complete black portion it has the intensity that is 255, and if we talk about the gray portion, then it has to be between 0 to 255. Okay. So, according to the intensity of each and every rectangle, that is nothing but it is the pixel of this digital image is actually giving the idea of digital image. Okay. So, that is all about the digital image, and by using this image processing image system, you can process this image into a digital form. Now, if we talk about the portion if we talk about the process between this image to this image, then by using sampling and quantization you can obtain this imaging system, this plane to this, you can move from this plane to this plane here only. Okay. So, these are the process. So, if we talk about the sampling process only, so see a continuous image f x comma y, if we talk about the digital image, then one of the function you can also identify at where x axis and y axis are there. So, using the x and y coordinate you can also present, you can also put the value of intensity as per the image is having. Okay. So, we want to convert to digital form, an image may be continuous with respect to the x and y coordinate, also in amplitude. If we are going to convert it into the digital form, then we have to sample the function and both coordinate in amplitude as well. To create a digital image, we need to convert the continuous sensed data into digital form. How we can convert this thing? Digitizing the coordinate value, which is nothing but it is called sampling. Digitizing the amplitude values is nothing but it is called quantization. Okay. So, these two things we have to distinguish each other, and after the combination of these two process you can obtain this from this image to this image. So, one is moved towards the 2 if we have these two process. This kind of process, sampling and quantization. Okay. So, I think I hope it is much better understandable. Now, see in a nutshell, if we talk about the analog signal, this is the analog signal. Okay. So, by using the sampling you are identifying the gap, that is the time period, sampling time period we can observe. So, using this time period T s, here you may easily observe that is the T s. Using this same time period you may observe the discrete point here on the x axis. On that discrete point it may provide the value according to the analog signal. So, these are the value. So, here you can say your signal is sampled, right, and after assigning the label, here we are digitizing x axis, okay, because the sampling portion we have to do. In previous slide we have also defined the sampling portion. Digitizing the coordinate values is called sampling, and digitizing the amplitude value. Now, see digitizing the amplitude value, this one. So, this is according to the amplitude value. On the y axis you are giving the amplitude value. Okay. So, see these are the amplitude value. So, by using this amplitude value, that portion is called quantization. So, both we have to use together, after that you can identify the digital image. Okay. So, that thing is actually useful to identify digital image from the imaging system. Okay. Now, if we talk about digitization of an image, now see that picture is very much important. Now, see that parrot has this portion, that is eye of the parrot, and if you zoom it, then see that black portion we have to identify, that black portion. So, now this black portion, how you can identify? In a digital form you can observe these grid lines are actually filled. Now, see neighbor of these grid line is also little bit filled. Okay. So, these portion is actually digitized, and you can identify the intensity of these filled pixels. Okay. So, how you can digitize that image using sampling and quantization process. So, that image is actually giving the clear idea about the digital sampling and quantization during the digital image processing. Okay. Now, come to this portion, come to this diagram. Now, here this is the A diagram, okay. This is the second diagram, that is B, this one is the C, and this one is the fourth diagram, that is D. Okay. Now, here we are moving from A to B, and according to the A to B, each and every pixel intensity you are plotting the diagram like this. See, at the point of A, the image is completely white. So, here we are assigning a label that is related to white portion. Again your B point is also a white. So, see, your B portion is also assigning the same label, that is white. Okay. Now, between the A to B, from this portion your intensity is actually changing. Okay. So, based on this intensity at that particular point, your pixel is going to be a black one, more likely to be black one. So, your portion is going abruptly change up to that point. So, that is actually giving the black pixel value. Now, after that, this black pixel you are moving towards the white portion. See, that is more whitish as compared to this one. Okay. So, your portion is actually going towards the white portion. After that, it will again going to be become a black portion. So, that is the black portion label. So, again it is going downward, and at that particular point it is abruptly changed and going towards the white portion. So, this is the scan line graph by which you can identify white to white portion means A to B portion, and based on this A to B portion you can sample each and every portion. So, here you may observe we are sampling this portion, this portion, this portion, after that this point, this point, this point, roughly I am plotting here. So, this is your sampling data, and based on this sampling data you can assign the label. So, see, these total 8 label we have assigned here. So, using the portion which is I am already talking about. So, this is the black portion, you may get that value. Okay. So, by using that value you may provide the complete digital information in each pixel. Okay. So, that is all about the sampling and quantization. So, if amplitude wise you are quantized, if you amplitude wise digitized, then you can say that is the quantization process. If you x axis wise coordinate wise digitize, then you can say that is the sampling process. Okay. So, that is actually the sampling and quantization process which I have talked about here. Okay. Now, if we see another slide related to digital image. So, here I am assigning a f comma x comma y, a function which is actually providing the information of each and every pixel. So, if we talk about this is the first pixel. So, it has the value that is f 0 comma 0. If we have 0 comma 1 pixel, then it is nothing but it is f comma 0 comma 1. So, on the row wise if we talk about, then these are the x axis. If we column wise we are talking about, then it is the x axis, and row wise it is y axis. So, number of columns and number of rows you can mark in this manner only. So, each and every dot is actually representing your single pixel. Okay. So, matrix representation of digital image is actually providing such information by which we can identify the intensity of each and every pixel. So, if we have m cross n image, or we can say m into n number of pixel, then you can observe each and every pixel in this manner, okay, from f 0 to f m minus 1 comma n minus 1, where n is nothing but that is number of columns and m is nothing but that is number of rows. So, in MATLAB, if you are using some of the tool to process a digital image, or we can say image, then we have to have such matrix representation. After that, each and every pixel can be enhanced, can be restored, whatever is requirement is desired, then you can operate accordingly. Okay. After that, some of the digital image data is presenting in this slide. So, see, as we told, as we discussed in previous slide, then each and every pixel having the different intensity. So, see, it has, that is the first pixel. So, it is nothing but it is f 0 comma 0 if we talk about first pixel, then it has the value that is 48, and if the last pixel if we talk about, then it has the 200 value. So, that is nothing but it is m minus 1 n minus 1 pixel, okay. And where m is nothing but it is how many, how much, tell me, 1 2 3 4 5 6 7 8. So, m is 8, and how much, how many the n, what is the number of n, 1 2 3 4 5 6 7 8, n is also 8. So, this is the value of 8 cross 8 image, and each and every pixel is actually assigning in this manner. So, if we talk about this portion, see, and we are focusing on this particular cell, or we can say we are focusing on that particular pixel, the neighborhood pixel we have to identify. So, these are called the neighborhood pixels, okay, by which that actually that pixel is actually associated, directly associated. Okay. So, these are called the neighborhood pixel. So, now see, the amplitude of the function of at any pair of coordinates x comma y is called the intensity or gray level of the image at one particular point. Okay. Now, so in previous slide we have completed the image, digital image, and how we can identify each and every pixel. Okay. After that, here I am talking about one of the important topic, that is called halftoning process. So, what it is actually? Halftoning or analog halftoning is a process that simulates shades of gray by varying the size of tiny black dots, which is arranged in a particular regular pattern. Now, see, it be if we talk about an example, then you can go through the newspaper. If you observe clearly that newspaper, then each and every image is nothing but it is the composition of dots. So, these kind of dots is actually giving the idea of this image in this manner. Why it is so? Because we are, if that gap is very tiny. Now, see, if the gap between these 2 points are very less, then your eyes is actually not observing that gap. So, it will look like a straight line in this manner. Okay. So, that drawback of your eye, our eye blend fine details and record the overall intensity. So, that actually the drawback of your eye. So, that drawback is actually giving the information about that particular image. So, your image is not look like in this manner. not look like in this dotted manner, it will look like a straight line in this order. Okay. So, that process is actually belongs to the half toning process. So, that thing is actually here we are talking about. Okay. So, spatial integration is very important parameter here we have observed. Okay. And this techniques is used in printers as well as publishing industry. Okay. So, that half toning process is very much useful to generate a newspaper which is comes from the printers. Okay. Very much large printers we are using to generate a newspaper. Okay. Press we can say the complete printer at where we can obtain the newspaper. So, that process is actually useful in that particular process. So, now come to the actually finding the idea of this, how we can find the idea of this half toning process. Now, see, the digital half toning is similar to the half toning in which an image is decomposed into a grid of half tone cells. Now, here we are talking about half toning and digital half toning. What is the difference between them? Now, here you can observe this is the half toning, or we can say analog half toning, analog half toning. Okay. Here we are taking the circle. Now, for the digital half toning, that dot is actually a rectangle. Why it is so? Why we are choosing rectangle only? Because rectangle is actually giving and it occupy complete paper. Your portion is not blank over there. Now, see, that portion is actually not covered up. Okay. So, that is the drawback of digital analog half toning. So, by removing this drawback, we have to have used digital half toning. So, each and every dot, if we are forming this image, then if we are taking that dot in a rectangular manner, then you can say the complete image can be formed. If we are choosing the circle form, then some of the portion is not completely filled. So, that is the difference between half toning and digital half toning. Now, see, shades of gray of an image are simulated by filling the appropriate half tone cells. The more number of black dots in a half tone cells, the darker the cell appears. Okay. So, these actually the giving the idea about digital half toning and analog half toning. Now, how many methods we can observe related to digital half toning? Here, because we are talking about digital image processing. So, we have to have focus on the digital half toning. We are not going towards the analog half toning. So, here we are talking about digital half toning. So, we have three methods. First method is patterning, second method is dithering, and third method is error diffusion. So, if we talk about the first method in brief, then patterning is come to the picture at where a pre-specified patterns we are using. Now, see what is the patterning? It is the simplest of the three techniques for generating digital half toning. Here each input pixel is represented by a different number of filled squares in a digital half tone. If we talk about 4 cross 4 grid, then only it represents 17 different intensity level. Okay. And the source image must be quantized. Now, see how we can use patterning process in digital half toning. So, here we are choosing the Rylander's recursive pattern. So, 17 total we have pattern we are matrix we are using, and by arranging these patterns we can form your complete half toning process in this manner. If we observe, if we have a quantized image in this manner, so we can say each and every pixel are having different values. So, see this pixel is having 0 value, this pixel is having 3, this is having 6 and this is having 8. So, according to these value, the pattern address is stored in imaging system, and according to this pattern address, using the Rylander's patterning, your image is arranged in this manner and that manner is serially passes towards the receiving end. So, after using this patterning option, you may observe your image in this manner. So, see, this is the original image and using the patterning digital halftoning process, you may get this image, that is actually quantizes the pixel values and maps each pixel to its corresponding pattern. These each pixel is corresponding to the Raylander's patterns and the resulting image is actually 16 times larger than the original one. So, this is all about the patterning digital halftoning. Okay. So, for this entire lecture we have taken these 3 references, okay. And third references, if we talk about recursive pattern, is actually giving the much more idea about this process. Okay. So, now this is all about the lecture number 5th and thanks all.